Welcome to ClickMyProject.com. Now we are going to discuss about the project particle filter based nonlinear data detection for frequency selective wave MIMO OFDM systems. Now we are going to discuss about the abstract of the process. Wireless channel change direction due to the mobility of the users, which coupled with the systems of the delay causes the outages channel state information, that is the CSI, to be used for transmitter optimization techniques such as the adaptive module. Channel prediction allows the systems to adapt the module methods to an estimated future CSIs. The primary contribution of this paper is the low complexity channel predictions method using the polynomial approximations. Due to the inherent time delay in estimations, processing and feedback, the CSI obtained from the receiver may become the outdated before its actual usage at the transmitted side. This system considers the time-varying channel as a stochastic wide-sense stationaries, that is the WSS process, and use the knowledge of the temporal autocorrelation function for prediction without explicitly modeling and physical scattering phenomenon causing the fading channels. Hence, in this process, having the two kinds of modules such as the sender side and then the receiver side. The sender side is nothing but the transmission side, and then the receiver side receives the signals. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. This process consists of the modules such as input data, pre-processing, data encoding, transmitter, receiver, and then finally performance estimation. In this first stage of the project, at first the input data is taken from the dataset, or else we have generated the random position of the nodes. In this process, we are generating the nodes based on the random positions. After generating the nodes, we just do the pre-processing. If the signal length is high, means the signal will be automatically limit the length of the signal, otherwise the signal length will be remains the same. After doing the pre-processing, we just move to the encoding. So in this encoding, we have done the serial to parallel conversion first of all to encode the data. So once the serial to parallel conversion is done, overall data type will be changed in this module. After the encode, we just move to the fourth stage of the project, that is the transmitter. In this transmitter, we have two kinds of modulations. The basic thing is BPSK modulation. Then the another kind of the modulation is an IFFT. So it is based on the BPSK is based on the 2AM modulation. So during the transmission, these three steps will be done to generate the encoded data. So after generating the whole encoded data, the purpose of generating the encoded data is to provide the security to the data. So after that, the receiver side will be asked to retrieve the original data from the encoded data. So the inverse process of the FFT as well as the BPSK will be done. Already we have done the IFFT process, so the inverse of IFFT will be the FFT. So after that, as usual, in the transmission side we are using the BPSK module. So in the receiver side also we are going to apply the BPSK module to retrieve the original data from the encoded data. After retrieving the original data from the encoded data, we have to compare the output data into one input data. So after the comparisons, we have to generate the performance parameters like SNR and the error rate. So once by using the SNR and the error rate only, we can justify our process is efficient. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015b and change the current directory. If you want to execute the process, just right click in the main.m and select the option run. Once you selected the option run, the process will be done automatically one by one. Now I will going to explain the results one by one. At first, this is the input data which we have generated randomly. After that, we have applying the IFFT. In case if the length of the signal is too much of long, means you can short out by using the signal limitation method, or else this length of the signals will remains the same. Now in the figure 2 it represents the IFFT data. Then this figure 3 represents the zero padding results. Then the result of cyclic prefix. These are the results consist in the transmission side alone, not in the receiver side. So zero forcing. So during the transmission and the receiver side, actually up to the encoded data, it depends upon the transmission side. Then during the receiver side it will demodulated. So you can see the difference between the input and then the demodulated signal. Somewhat the data versus losses in the decoded side. So we have to estimate the performance to whether the every node is optimum or not. Now this is the performance of the input as well as the output. When we compared with the input and output, the zero forcing results for 64 km and 16 km was plotted here. Now you can see the variations of the 16 km and 64 km. After that the MMSC values of 16 km will be 16 km, 64 km will be shown like this. Now these are the performance graph we have estimated in the below things. Thanks for watching this video.